Today, I want to introduce you to the difference of squares. Now, what is the difference of squares? The difference of squares is a factorization formula that says this: a squared minus b squared equals a plus b times a minus b. Okay, this is our factorization formula, and this is a super powerful and useful factorization formula that you will use for your entire math career. So let's say that we had 9, actually, we'll do 9x squared minus 16. How can we factor this? Well, what we want to do is we can say this equals, and so this is our a squared. So 9x squared equals a squared. So if a equals the square root of this, the square root of 9 is 3, and the square root of x squared is x, so 3x. Then 16 equals b squared, right? So if we just want to figure out b, we take the square root, and we get b equals 4. So then we can say this equals 3x plus 4 times 3x minus 4. And if you want to check this, you can expand it. Let's expand it. So we get 3x times 3x. That's 9x squared. 3x times negative 4. That's minus 12x. 4 times 3x. That's plus 12x. Then positive 4 times negative 4 is negative 16. These two will go away, and we're left with 9x squared minus 16. Right? So perfect. That's correct. Now, let's do another one, but let's make it a little more tricky. Let's make it so we have 71x squared minus 2, right? So you have this, and you want to factor it, right? But these are not perfect squares, right? 71 is not a perfect square, and 2 is not a perfect square. So how can we do that? Well, it doesn't need to be a perfect square. We can just say a equals the square root of 71 times x squared, which will also just equal the square root of 71 times x, right? Then we can also just say b equals the square root of 2. So if we want to factor this, we can say that this is x times the square root of 71, right, plus the square root of 2 times x times square root 71 minus the square root of 2, right? So as you can see, we have factored this, and these weren't perfect squares, right? So they don't have to be perfect squares. Most of the time you're using it, they will be perfect squares, but they don't have to be perfect squares in order for you to use this, right? Let's look at another example. Let's look at, let's do 16z squared minus 25, let's see, what's another variable? P squared. How can we factor this? Well, we have a variable here, but we also have a variable here. Well, we have two variables, so you might think it might change, but it won't change at all. It's going to be the exact same thing. Take the square root of 16, that's 4. Square root of z squared, that's z, 4z. Then plus square root of, what's the square root of 25? 5. Square root of p squared, p, right? And then you just repeat this, but with the negative symbol, right? Or with subtraction. So here we have factored that, right? So we can even do it when it has two variables. Now let's do one last one. Let's do, once again, we'll do 16 and 25 again. 16, I'll do the same number, 16z, but this time z is going to be 2 to the 6th minus 25p to the 4th. Now, how can we factor this? Well, once again, we do in fact have perfect squares here, right? We just have to think about it. So 16, square root of 16 is 4. We already know that. That's easy, right? But then z. Z is where we run into some issues because we don't have z squared. We have z to the 6th, right? But what do we know about multiplication of two numbers who are raised to a power and the bases are the same? We know x to the a times x to the power of b equals x to the a plus b. So we can factor this, right? What we want is z to the 6th, we'll just be going backwards, equals z to the 3rd times z to the 3rd, right? So we can say this equals z to the 3rd, right? Then we have plus, then once again, square root of 25 is 5, and then p to the 4th. Well, we can just repeat the same process, right? And we'll see it's p squared. And then you just finish it off, 4z cubed minus 5p squared. And there we have factored that properly. Thank you for watching. Let me know if I said anything wrong. Thank you. Have a great day.